Okay, for one last lecture, we're going to talk a little bit about the effective class design and also kind of drawing debug lines in Unity. I think this is going to be a duplicate slide. Sorry. Okay, let's talk about effective class design first. So think about this asteroids game that you're making. What does the class structure look like? You know, let's just say this is sort of the minimum acceptable number of things that you would probably need. You need your main project. You need the asteroids because they're floating around doing their thing. You've got the ship, right? The orientation of the ship and the vehicle, and also bullets, right? Because you're shooting bullets and what those are doing. Um, this is sort of the minimum, right? Like, here's a little bit about what each one could contain, right? The main project has the asteroids, the bullets, your object. It contains everything there, how many lives you have. The asteroids, each one of them contains like its orientation, how does it interact with a bullet when it hits, and this kind of things, like how does it break into smaller pieces, and you have to update its position and draw itself to the screen. And the ship, same idea, right? Your position, your orientation, the bullets, all that stuff, and each one of these will handle the interactions individually. So, what are some of the issues, right, with this kind of design? Well, each class is doing a lot of stuff, and so the question is, right, can we break it down? Can we make it have less stuff? Well, let's say that we added a bit more organization. So now in our main project, we have an asteroid manager object. So instead of the main project managing it directly, we have another object that is now managing those objects and handles the braking and the dying and the collisions and all that stuff. And then we also have a bullet manager, which again, same thing. So you can kind of see this manager pattern works particularly well for a situation where you have objects that are being instanced and created and destroyed and interacting with each other. Um, and so now instead of the main project managing those things directly, it's managing these managers, which now have broken them down to sort of smaller and smaller components. So the question is, can we do it even more? Can we break it down even further? And so here's kind of another idea, right? We have a GUI manager, and that handles the graphical interface, like how many lives do you have left? What's the score? We have an input manager that manages the keyboard and dispatches it to the correct place, instead of having that behavior all happening inside of these objects. And now your main project manages all of those different managers and keeps things in order. So the design of class structures is really important in building multimedia, like interactive experiences. There's a lot really going on underneath the covers in any game. You have all these different objects and behaviors and situations, and you have to test for a lot of different situations and so on. And so it's quite important. And here are some ideas and thoughts around, architectures and things. And hopefully this will give you some good some good additional knowledge of what to think about in future projects as well. So one thing should be added too, like just because this lecture is here, don't go and like throw everything away. Like try to take what you have and turn it into a better design. Good architecture tends to be revisiting ideas and refactoring. It doesn't mean rewriting. Don't rewrite. You should rebuild, rethink, refactor, but don't throw code away and then rebuild it from scratch. That's not the point. Um, so one thing that is really, really good to do is to sketch things out on paper ahead of time. Sometimes it's just a bunch of boxes. Sometimes it's just a couple of lines of like this X, Y, Z, do these things. Sometimes it's deeper, like a full specification design sheet that you get feedback on from different people. But there's a sort of magic amount of pre-planning that you should do. It tends to be like 5% of the time of any project should be dedicated to design and planning. So you can kind of think about, well, if I have a 2-week project, right? What is that, like 10 days, the work days, say, right? 5% of that is going to be half a day of planning. So that makes sense, right? Sorry, wait, 5%, 1%, yeah, right? Yeah. No, 10% of 10 is 1. So, no, say it's like a half hour. So yeah, if you have a week long project, sorry, it should be like a half hour or an hour of planning. If you have a 1 year project, right, 365 days, then you want to spend almost like a week of planning. And so there's a very big difference between 2 weeks, 10 days, or 365 days. So yeah, generally speaking, the magic number tends to be 5%, 5 to 10% of your time should you spend planning before you dive in. Um, you know, cool, love it. I get phone calls in the middle of lectures. So what classes are necessary? What do you need, and what do you not need? So in the project, in the asteroids project, at minimum, you kind of do need like an asteroid or enemy or like a main ship character and a bullet. Like those are pretty clearly necessary. They're going to be objects. You're going to have a class for them. And you also need to know what kind of holds what stuff. And so what kind of data structures you're going to use for keeping track of instances. There's going to be a list. You need a tree. How are you going to do that, right? Do you need to index it? Do you need to sort it for some reason? Do you need to, for example, you have bullets and you're shooting bullets and you want to know which bullets are off the screen, and the ones that you just shot recently are probably not going to be off the screen. The ones you shot a while ago are. So ordering things in terms of time might be what you want to do to keep things optimal. So there's a lot of different ideas of how you want to organize information and objects and so on. And so the other bit is, in this case, in this game, how are things going to collide with each other? How do you know when things collide, and how do you get that information, right? Does the ship test for collisions against the asteroids? Does your manager check that? Does the asteroid check for collisions? Like, who's going to do it? Is it going to be a manager, right? A collision manager? You want to kind of offload it to there, right? And the reason you might want to think one over the other is having two things do it is not efficient, but also it's about the coordination or the orchestration of these checks, right? If the asteroid checks something that is related to the ship doing something, and the ship then checks it separately, and they're not doing it at the exact same time, your game may get into an inconsistent state. So for example, say your ship and a collision with the asteroid is checked before the bullet, and then you shoot the bullet, but the bullet's looking at old state when it checks the collision, and it thinks it hits the asteroid, like what wins? So you have these race conditions. So you really do need to kind of architect this out and kind of think in your mind, well, this happens and then this happens and this should happen, and design the program in that way and design the architecture to follow that way. So splitting the code up into smaller classes is really going to help you in that you really can kind of now decide where things happen, who owns what, and then maybe have a separate collision manager to manage and have access to all of those different objects and different things and kind of make sense of it in one foul swoop. Like for example, if you've got the ship, the bullet, and the asteroid, and you have a collision manager, that collision manager can say, okay, here's the state of these objects, and here's the outcome. So there's only one. There's not like 3 different events that occur, and you have to figure out which one happened first. You have this manager that determines, well, you know what? It looks like the ship crashed into the asteroid right as it was shooting a bullet, but it still crashed into the asteroid, and that's what takes precedence, and ignore the other events. So an example is, right, a scene manager, and that manages the whole thing. You have bullet and a bullet manager, a collision manager that makes sure that everything is, and throws out events, and then manages the behavior of things. You have an enemy and an enemy manager, an asteroid manager. You have a GUI manager that kind of represents the display to the user of how many lives, like what the score is, all that stuff. And then you also have an input manager, which takes the user input and sort of spreads it across to whatever need be. And then you also have a ship object, which is, so this allows you to have much smaller objects and much more manageable code in the long term. So yeah, again, as I mentioned before, like don't just go, let's like rewrite everything or like throw stuff away. Like start small, start subtle, get used to this. Architecture is a lifelong pursuit, I would call it. The closest thing to Zen in programming that there is. There's this, I like to think that good code is not timeless. Like good code is obsolete as soon as you write it, but good architecture is timeless, right? Ultimately, you'll find these design patterns, you'll find these things that will come up time and time again, and every time you do it, you just do it like a little bit better. And then over a long enough career and enough experience, you just get really comfortable doing that stuff. And that you never quite solve these problems. These are like, how do you build a big project? How do you solve really hard problems? Well, architecture is, in my opinion, one of the best tools that you have in your arsenal to really tackle hard to solve problems. There are plenty of examples of like this not happening. Like Bitcoin was like some really ugly code. It was just like, and like there was no architecture, yet it was still Bitcoin. But for the most part, right, applications like operating systems like Linux and compilers and some of the most kind of aggressive computer science projects and problems that you need to solve. Sure, you can solve them with algorithms and make the thing that's 10% faster or whatever, but that's not necessarily as important as building a program and an architecture and a solution that scales. And you can see that in applications that are timeless, in operating systems that still effectively work the same way for decades. And it's not because that they're old and decrepit, it's because that they solved the problem in this general way and are continuing to making that more and more and more general. Like the Linux kernel is only 50,000 lines of code, right? There is not like, oh, we need to make it more code, right? Whereas by comparison, the Chromium, the Chrome browser is nearly 10, 11 million lines of code. But that's because we're constantly adding more and more stuff to it, but the kernel of that code hasn't changed substantially in terms of size, but just has improved in architecture and stuff like that. So honestly, this bit, separate from making video games and making interactive experiences, like as a programmer, as a developer, as a builder of things, as a person that wants to solve big problems in the world, architecture is like a big deal. So Unity has some really nice visual debugging features, and we'll talk a little bit about why that's important. So imagine this asteroid game. There's a lot of stuff going on here. Just looking at this image, you can't deduce what the next frame is going to be, right? These asteroids may be rotating, they might be going in one direction. You don't know which direction that is. The bullet is going, we just see a dot. We don't know which direction it's going. Like we had automatically assumed like, oh, the ship is going in this way, but maybe it's going this way. And the user is applying a force in the opposite direction because he doesn't want to crash into that asteroid that they're about to crash into. So having information visually available to us as developers might help us debug what the heck's going on in here, right? So a debug line is something that Unity allows you to draw, and it lets you use them pretty much in just a debug mode, and it's not going to be actually exported to your project, so only you'll be able to see it. These lines can be really helpful to really understand if your objects are moving along the correct path and if they're facing the correct direction, right? And so, for example, in that previous example, like we can see, oh, the direction of that asteroid is actually going this way, this one's going that way, the ship's going in this direction. And you can kind of see that then if we know that information, we can assume what the next frame is going to look like. We can also play with bounding debug lines. We can determine if our objects are colliding properly. We can change the colors of things of those lines to come up with realizations like, oh, it's colliding, it's not colliding, there's a bug here, and so on. There's no circle debug lines, but you can create a bounding lines around an object and make it look more circular if you'd like. So for example, bounding circles versus and color changes can give us information of when things are actually taking place. So there's a couple of functions we're going to go through: debug.drawLine, debug.drawArray. These are not going to be visible in the game view, and they're not going to be visible when you export your build, but they will be visible in the scene view. And you can also turn them on in the game view explicitly, but that's like, I'll show you how. You can click the gizmos icon and it'll show up for you. So let's try to do a little thing here. There are some optional parameters like the duration, which will allow you to make them go away. So let's do that for our game here. Cool. So what I want to do is, when I rotate, I want to draw a debug line, debug.draw line, and it's going to start at my transform position, and then it's going to end at transform position plus heading. And what I'm doing there is I'm simply drawing from a point to another point, and I'm going to give it a very short duration because I want it to go away. Why am I getting a... Oh, the color. I also, if I want to use this, I need to use color. Let's make it green. Cool. So now I anticipate seeing some kind of green line. Whoa. You can see when I'm rotating, it's drawing that line. So I can see which direction I'm rotating to. Great. It's only going to be viewable in the scene view, like you saw, but I will show you down here in the right corner, top right corner of the game view, you can turn on gizmos. And when you turn on, like, there's a little button that says gizmos. If you click on it, then these will be seen in the game view as well. But that's just sort of whatever. And if you turn it off, whoops, turn it off, it will turn it off. It's good to know. So to draw it correctly, what we just saw, you want to have your position, you want to do it, but sometimes it's not going to be necessarily right. You have to kind of think in vectors, right? Say I want to draw my velocity or my next position. I'm actually going, you know, from the vector. Say I want to be drawing, you know, the direction of the ship. I may be taking the position and the direction are two different things because, you know, I'm starting at the position of the ship, but then I'm going in my heading is different than the direction that I'm actually moving, right? So we need to kind of understand that direction is normalized, that it has a, you know, coordinate between 0 and 1, and on its own it's relative to the origin. And so kind of we did this already in this case, right? Because we took our position and we applied to it our heading. And our heading already kind of took that into consideration. Like, for example, if we did the same thing as I did prior, let's do this. Let's put this into here, right? And let's make this yellow. And I'm going to set my velocity. So now I'm taking my position, and I'm going to make this really short because we're going to render this almost every single frame, not only when we hit something. So notice now, maybe it's too short. Okay. So now my velocity is going to be 0, but when I move, you'll see this line kind of following me. Maybe it's still too short. We should give it a bit longer so we can actually see what's going on there. And you'll notice that the two differ. We need to increase this because I want to see it looking ahead. So now you can see how my velocity and my acceleration do not necessarily. Let me increase this as well so we can see how the acceleration, the heading, and the velocity have two different directions. Oops. Right. Notice how different these things can be. So you do want to kind of pay attention to what you're actually recording. Yeah, so as we were saying, right, like they're drawn from one vector to another vector, and the direction vectors are normalized. The magnitude needs to be taken into consideration. And so if you're not adding it to the right thing, if you're taking the velocity and you're adding it to the acceleration, you're going to get like a wackadoodle thing. It's not always necessarily the right thing. So you have to really think in vectors and think in the context of the object and what you're actually doing in the manipulation you're trying to visualize. And so in this case, right, we want to apply the position plus the direction, not going from the position to the direction, which is going to give you some arbitrary doodad. Another debug line, which is called array, it's going to be a line from one point along a direction vector. So you start with a position and a vector. This will actually solve some of those problems where it's like, say I want to have a heading, I can give them a position and a heading, and it'll be a little bit better. So like, for example, if I go here, I can instead go draw ray, and everything is the same, except now I don't need to add this position, right? And same thing here. If I go draw array, and I can get rid of this. And what you'll get is allegedly the same thing. Right? Great. So it looks the same. So cool stuff. Now you can use these lines to kind of debug what you're doing, and it's they're really powerful, right? And you can create custom functions to draw special lines, like a circle or whatever. You can change the colors of these to create really good indicators of what's happening, and so you can debug your code and your project pretty well. So a couple of reminders. Midterm exam is going to be on the 15th. I'm still figuring out how this is going to work. This is an online class, so I'm not sure exactly how the midterm exam is going to be proctored, but I'll get back to you as soon as I can. And the asteroids project is going to be due on Tuesday on the 15th as well. So you've got some time to work on it, but do not procrastinate. Do it now or whenever. Like, do it whenever you can, but do it soon. Don't like wait until the day before. Also, like, this is an online class, so you do need to do the exercise to kind of give me a checkpoint with what you're working on. If you need feedback, if you need help, like, use office hours. That's what they're there for. If you're having trouble, like, really reach out. Right now, my office hours are set to half the day on Tuesday, effectively, so there should be plenty of time for you to jot some time on my calendar, and we can jump in. I can look at your code, and I can help you out. Great, and that's about it for this week. Thanks again, and hope you get to building some cool stuff. I'm excited to see it. All right, bye bye.